This is the Bear Tilda Mark E board from 2014, which we had a few hidden achievements on them for anyone that managed to find all 3 achievements by unsoldering their badge. It was quite funny. Achievement 3 unlocked, desolder master, and this one is RFB, achievement 2 of 3, RFB gone. We had a radio chip there 2 years ago, and achievement 1 of 3, behind the veil. Put the screen back on. So that's 2014, the second EMF camp and the second badge. Tilda Mark Pi, so we have Mark Pi and as I say, Pi to 1,000 decimal places. This is one of our empty boards from 2 years ago. So you can see here actually with these the progression of the shape, but it doesn't show up so well on there. But yes, we've got the similar sort of curves, and then we've grown the board. We've turned the screen from portrait to landscape, from landscape to portrait, added a lot more buttons. So an evolution. So these are 4 pages of schematics. So starting at the top, this first page is mostly the processor, so the MSP432E, and it's broken down into sections of the processor. So these boxes make up the 128 pins of the processor and all the interconnects. So these are all these connections go to elsewhere. We have Ethernet expansion headers, the Grove expansion headers, the conductive thread headers, the USB port, the 8 megabytes of SD RAM chip. This is the 1 megabyte hard drive. These are the debugging and programming headers. This is how we fix it when it's broken. The big center of this is the power system. So we have the battery connection, power goes into the battery charger, and also power comes in from the USB connection into the battery charger, and that then passes it out through the switch and off to the 3-volt regulator, which runs all the electronics on boards. The GSM module is tapped off before the 3-volt regulator to get that extra power that it needs. LCD screen connector. Buttons, lots of buttons, and the joystick. Most of the buttons are attached to this I2C port expander because we ran out of pins. The 2 LEDs, the red-green LED that are on board, the solder your own LED, and the 2 NeoPixels, WS2812Bs. And then we have our TI sensors. These are all on, 3 of these are on I2C. So we have a temperature TMP 102. The HTC 2080 is a humidity and temperature sensor. That got added late, which is why we've got 2 temperature sensors. The lux sensor on the front, the OPT 3100, and we have an on-analog channel. We have a Hall effect sensor, a DRV 5055. Some of these are cutting-edge new devices from new releases from TI. And our sponsors have helped us get those on the board and configure them and work for them. This sheet is the Wi-Fi module. So we've got the main Wi-Fi module and some of them broken out. The Wi-Fi itself has its own 2 meg hard drive to store its firmware to run off. So there's another SPI serial flash chip. And then the interconnects back to the MCU so that we can talk to it. We've got an SPI bus for the daily use, and we use a UART to bootload that firmware on when we first turn the badges on. And 2.4 gigahertz chip antenna, which we've not matched because we didn't have the time. And on the last sheet is the GSM module and the audio. So again, we've got the GSM module, UART connection or UART serial connections back to the MCU. Connections to the SIM card holder, GSM antenna, GSM coil antenna, and the Bluetooth chip antenna, and audio. So we've got audio coming from the GSM module, going through some filtering to an amplifier and to the speaker on board, and audio from the MCU can also get muxed in, so that you can play audio chip tunes out of the speaker from the MCU. And this op amp here allows us to listen to the incoming audio on the call on the MCU, so we can decode those telex tones if we can get them going. And over here, similar setup, we've got audio from the GSM module coming through some switches and going to the microphone, and this is that hardware disconnect. And again, we have the ability from the MCU to inject audio over the phone call. And then the one bit that didn't work, or we couldn't get working, there was supposed to be a headset jack for for headset, for directly plugging the headsets or headphones, but unfortunately we didn't get the wiring quite right. It was the last minute, 30 minutes before we sent the designs off to China. Can we squeeze this in? It may work. We'll test it when we build the first boards. It didn't work, so we've left it off the board this year.